Okay, year 8, so this is probability lesson 3. Last lesson we have learned how to construct our Venn diagrams and also read data for the Venn diagrams. This lesson we are going to learn how to use Venn diagrams to calculate the probabilities. Alright, and this probability will be the probability using the word and the word or. Okay, so that means we are going to see the combination of two events rather than just one event. Okay, let's see what happens. For example, if you are provided with a Venn diagram showing students' favorite fruit. Again, we have seen this Venn diagram last time, so you should be pretty good at recognizing the meaning of each number. For example, the number here means there are 13 students who favored both apples and bananas. And so, how about the numbers in the green color right now? They are all in the circle labeled by A. That means there are 10 plus 13, which is 23 students who favored apples. And how about the circle B? There are 28 students who favors bananas. Alright? And we should all understand, outside the two circles, there will be some students who do not favor apple or banana. Okay? So this student, what we call, there are 12 of them. Okay? And so how can we find the probability? To find the probability, first you need to know how many are the total, because if we have a little bit review on the idea of probability, for a certain event E, probability of E is equal to number of favorable events, number of favorable outcomes divided by total number of outcomes. And total number of outcomes here just refers to total number of students in the Venn diagram. So how many of them? Okay, so that's the first task you need to understand, is the total number of students. And we understand that the total number of students should be 12 plus 10. I'll use another color. Should be 12 plus 10 plus 13 plus 15. So there are 50 of students. And let's see some probability. Probability A means apple, means probability of selecting a student who favors apples. So how many of them? That means students in the circle of A, there are 10 plus 13 number of students. Since this is probability, you need to use that number divide by the total number of students, which is 50 now. Alright, so there is the answer. And how about probability B? Probability B means probability of selecting a student who favors bananas. Okay, so how many of them preferring bananas? 28 of them. So it should be 13 plus 15 for 50. So there are 28 of them. Alright, so this will be, when you simplify them, it becomes 15 divided by 25. Okay, you could do that through your calculator. Still remember how to use calculator to simplify a fraction? Okay, so that's a button in your calculator indicating this one. Okay, so if you do the calculation, it might show you a decimal number. If you use this one, you just change back to a fraction. Okay. All right. Okay, so let's see the last one. Okay, so sorry, not the last one, just the next one. This is probability A and B. Okay, so this is a new thing, and that means you need to satisfy both A and B. What do you mean by satisfying both A and B? That means in this context, that means probability selecting a student who favors both apples and bananas. So how many of them are favoring apples and bananas? It should be 13, right? So there are 13 of them, but again, so since this is a probability, you need to divide it by 15. Okay, so this would be the lowest form. We can't simplify any further, right? So this is really the last one, A or B. Okay, so let's compare. And A and B, that means student who favor both apples and bananas. But for probability using the word or, that means who favors either apples or bananas or both. Okay, so what do you mean by favoring either apples or banana or both? Okay, so that means all students either in circle A or in circle B or in both of them. That means or A or B. How many of them? There will be 10 plus 13 plus 15. So there are 10 plus 13 plus 15 of them, divided, of course, again 15. So for the calculation, you will have 38 divided by 50. Again, if you use your calculator to simplify it, it will be 19 over 25. Alright, that's it. Okay, so let's look back again. What's the difference between the word and? What's the big difference between or? One is a probability using and. That means you need to be in the intersection of two circles. Okay, in the overlapping area of the two circles. If that's the probability using word or, that means you need to be in either of the circles or in the both of circles. That means as long as you are in any part of circles, okay, you should include the numbers. Okay, good. Right. So that's our first illustration. Then we go to example 1. Example 1 again is a situation we've seen before. So this is a Venn diagram showing favorite spots of a people in a community. Okay, so in this community, you see some people favor some people favor rugby, some soccer, and some neither of them. Okay, so in the circle of rugby, and there are 70 of them, which who are in the overlapping area of both circles. That means there are 70 people who favor both sports, and 250 means people who only favors rugby. So here, this group of people only favors rugby but not soccer. And for 120 people, they favors only soccer but not rugby. For 70, they favor both. And for 330, that means there are some people who favor neither of the sports. Alright, so let's see the probability. To find the probability, you need to find the total number of people, otherwise it's impossible to do the calculation. So let's find the total number of people. The total number of people here, you just add up all the numbers you see in the Venn diagram. Okay, so there were 770, right? And the probability is that a randomly selected person favors Robbie. Okay, so may I just use R to indicate that's the events of a person favoring Robbie. Okay, just P bracket R. Okay, how many of them favoring Robbie? Okay, they must be in the circle of Robbie. Okay, so there are 250 who likes Robbie only, but there are 70 who like both. So those people are also like Robbie, aren't they? Right, so need to simplify that. Okay, so use your calculator. You will see the answer like this. Alright, let's move on. Find the probability that a randomly selected person favors soccer. Okay, favors soccer. That means they must be in the circle of soccer. How many of them? Okay, you could see there are 70 and 120. So may I use S to indicate a person who favoring soccer? Okay, so there are 70 plus 120 this time, and we use this number to be divided by the total number of people. Robbie. Okay, so sorry, do too quick. Find the probability that a randomly selected person favors both Robbie and soccer. Okay, so it's about probability of n. So that means Robbie will use R and soccer. Okay, how could we calculate this? Okay, so remember when you see the event is using n to link up two separate events, so we go back to our Venn diagram. Okay, so this time you will see we need to consider the number okay, in between the two circles. Okay, let me copy circle, so I need to emphasize this a little bit more. Okay, let's make this smaller so it's easier for us to see. So which part are we interested now? This part, right? Use another part. Okay, so that part we have 70. Alright, so you got 70 divided by the total number. When you simplify it, you will have this one. Alright, and okay, so remember this, if this is rugby and soccer, you can only count those people who love both sports. Okay, so you don't need to worry about the numbers in the rugby circle but not in the soccer circle, and also those numbers in the soccer circle but not in the rugby circle. You must need that numbers in the overlapping area. Alright, so let's go to another one. Find a probably that randomly select person favors either, so here's the okay, either rugby or soccer or both. Okay, so that means you are considering people who either love rugby or soccer or both sports. Alright, so how many of them, and which part of Venn diagram are we going to consider this time? And let me just put that here. Alright, so this time apparently we need to include all numbers in the two circles. Okay, right. And so probability, let's write the probability as rugby or soccer. Okay, we'll use the word or this time, and then it will be alright. So that's it. So you will have this one, and this one is all good. Alright, so you see the difference between and or. Okay, so what part of diagram are we going to use? Find the probability that's a randomly selected person, neither rugby nor soccer. Okay, which part of the diagram are we going to use? Oh, sorry. Seems a message. Okay, so since this time neither rugby nor soccer, so you need to find those people who are not interested in either sports. Okay, it should be this part, right? Okay, so in this case, it should be probability. Okay, P nor S. Okay, then we use the numbers outside the two circles. Alright, so I should have 3 over 7. That's it. Okay, find the probability that's randomly selected person favors only rugby. Okay, this time only rugby, so that means which part are we going to consider? Do we need to consider some of people who not only favors rugby but also soccer? Okay, let's consider this. Okay. Let's move our Venn diagram over here. Okay, so let's see. Favors only rugby. That means not soccer. Okay, so which part? Is it this part? Okay, so if we include that 70, so that's some problem because that 70, these 70 people, they also love soccer. So it's not just about only rugby as their interest. So I should say the number we're interested in now should be 250 only. So probability of R only, alright, should be 250 divided by total. Right, so it should be like this one. Okay. The last one, find the probability that a random selected person favors only soccer. Okay, so it would be the other way around. Okay. I need to. Okay, we will get that. Okay, got it. So this time favors only soccer. So the keywords only rugby there, only soccer here. Alright, so it should be only soccer. I think it should be only that part. Okay, the same idea as the last one. Okay, so this time S only. That's S only. Should be 120 only. Alright, and here's the answer. Okay. Okay, so let's see, we have a different selection of parts of our Venn diagram, and you need to relate the words to the diagram. Okay. For example, when they mention both R and S, you consider the overlapping. Either R or circle or both, you consider all the areas in the circles. Neither R nor S outside two circles. Only R, that means in R but not in minus the overlapping. Only soccer means in S minus the overlapping. Alright? Okay, let's move on. Let's have another look. Alright, so this time we are going to do the laptop and desktop one. So we have done that last time, haven't we? So again, so it's about a lot of people who might have desktop, who might have laptop, who might not have either of device, who might have both device. Okay, so if you still remember, we construct our Venn diagram last time. Okay, so to do the following probabilities, you need to construct your Venn diagram. Okay, so before we construct the Venn diagram, the first number you need to know is the total number. Okay, always get the total number first. So how many of them? Okay, so when you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and another 10 here, so that should be 20 because it says so, 20. Okay, so there are 20 students and you need to draw a Venn diagram. Okay, so what kind of circle do we have? So there are two main categories. One is desktop, so we use this blue color, so let's use blue color. Okay, and also the laptop, okay, and laptop we use the red one, suppose. And also we have certain people who have both with green color, and some got neither, we use black color. Okay, so let's write the number. First, remember to construct the Venn diagram, you always need to fill up the numbers between the two circles. That's the overlapping one. So those would be the number of the green color because they have both desktop and laptop. Okay, so how many of them? Okay, so when you look at the green color right here, there are 4 of them, are they? Alright? Okay, so let's look at how many in the other one, in just desktop without laptop. So 1, 2, 3, 4, 5, 6, 7. Okay, so 7 of them. And how many of them they have laptop but not desktop? Okay, red color, 1, 2, 3, 4, 5, 6. Okay, 6 of them. Okay, in the end, how many of them outside the two circles, they don't have neither of them? Okay, they don't have any device. Okay, so this will be 3. Alright, so here's the Venn diagram. Alright, okay, so let's find out the answer. Okay, so I need to make that diagram really small now. Okay, alright, so I need to get extra small. Okay, right, so find the probability that randomly select student owns a desktop. Okay, so as long as you are in the blue circle, you will satisfy this condition, right? So let's write it should be probability owning a desktop PD. Okay, how many in that circle D? We will see. Okay, so this is the circle. So there are 7 plus 4. Okay, divided by total number is 20. Alright, And the next one, okay. Okay, next one is about a laptop. Okay, let me make it really small, Okay. Okay, possibly it would be smarter for me if I copy this many times rather than do it every time. Okay. Alright, seems that looks fine. Okay, so let's see. If we only consider student owns a laptop, so here should be the number. Okay, so should be just like 4 plus 6. So laptop 4 plus 6 divided by 10, 10 over 20. Use your calculator, you see that should be 1/2. Okay, so next one, probably the randomly select student owns a desktop and a laptop. Okay, so it's about 2 events using n. 2 events using n. Okay, so which part of Venn diagram are we going to consider this time? It should be in the middle. Alright, so in the overlapping area. Okay, so this one should be only 4 of them divided by 20. Okay. Okay, next one. Find the probability that a randomly selected student owns either a desktop or okay, a laptop or both. Okay, so that means you include all the things. Okay, if you include all the things, that should be looks like this to me. Alright, all the things. Okay, so probability of desktop or laptop. Okay, or both. Okay, so it should be 7 plus 4 plus 6, 20, 17. Okay, 17 plus 20. Okay, find the probability that a random select student owns a desktop only. Owns a desktop only. Okay, so that means we only consider those who only owns desktop but not laptop. Okay, so which part are we interested in now? Should be this part, right? Alright, so this time we say D only, 7 of them. Okay, and the next one would be laptop only. So laptop only. Okay, so laptop only. Alright, so should be this one, only laptop but no desktop. Alright, okay, so should be 6 of them divided by 20, and this one need to be simplified by using calculator. Oh, good. Alright, so another one is about playing cards. Okay, if there are 52 playing cards, so we understand that 4 suits of them. You got hearts, you got club, and also you got diamond, and also you got spade. Okay, right, so and first one you need to consider, for if I just draw one playing card from the deck of 50, so total number of outcomes would be 52. Find the probability that the card is a spade and a king. Okay, so it's a spade and a king, so it's actually the combination of 2 events, so you need to consider spade and the event king. Alright, so let's see how many spades are there, how many kings are there. Alright, okay, so when we consider the diagram here, what are the spades? Spade means, Okay, I'm going to highlight this, so I need to watch carefully. Spade means here, so the part I highlighted is a spade. So how about king? King is over here. Okay. Alright. So how many spades are there? So there are 13. Okay. 13 spades. How many kings? There are 4 kings. Okay. So are there any card which is both a spade and a king? Yes, that's one. That's called a spade king. Alright. Okay, so how could we sketch construct a Venn diagram to represent this? Alright, so okay, so possibly I should copy this here to make a better illustration. Again, I have to make it smaller. Okay, and then I'm going to translate that into a Venn diagram. Okay, so possibly I need to get each question with that of card like this. Just easier for me to do the discussion. Okay. Alright. Okay, so and going to draw the Venn diagram as well. Okay. Alright, so let's draw a Venn diagram. Alright, so the Venn diagram will be like this. Okay. Yeah. Sorry about this. Okay, so we need 2 circles. Okay, one circle like this, another circle. Okay, and this will happen every time. So let me just copy and this, and so I don't need to do it every time. Just easier for me. Alright, just easier for me. Alright, so let's see. Spade and king. So let's write S here, king here. Right, so spade. How many spades over here? So there are 13 spades, there are 4 king. Okay, but remember whenever we are going to construct a Venn diagram, you always need to consider the overlapping part first. So what are the numbers in the overlapping part? Remember that for spade. Okay, let me amplify this a little bit. For spade, there are all the cards here. These are all called spade. And for king, possibly I need to use another color. Right, king. Okay. So how many cards in both regions? There should be 1. Okay. And so how many cards which are spade but not king? So there are 13 of them for in spade, but now only 12 which are spades but not king. How many kings? There are 4, but there's only 1 spade king, so 3 of them are not spades. Okay, so how many cards are not spades nor king? Okay, so there are the rest of them. Okay, so should be how many of them? Okay, should be 3 layer, each one got 3, so should be 33. Okay, so if you don't know how could I get this number, you use 52, take away 12, take away this one, and oh sorry, 36. Sorry, my fault. Okay, should be 36. And alright, so let's see. how could we find a spade and a king? Okay, probability of that. Okay, probability spade and a king. Okay, so which area we are interested in now should be this part. So that's only one of them out of 52 cards. Okay, then move on to next one, spade, king, but this time we're using OR. Okay, so when we use OR, let's fill in the number again because this still spade, king discussion. Alright, if we are talking about OR, that means either S or K or both. Okay, so we need to consider all the parts. Okay, so whenever you see OR, that means all the parts, right? So it's like probability S or K, it should be 12 plus 1 plus 3 divided by 52. This one should be 16 divided by 52. Okay, find the probability that the car is a number car and a heart. Okay, what are number cars? That means the car. There are two types of the car. One is a face car, the other are numbers car. Okay, face car you see some people there, so with their faces, so these are face cars, and numbers car just the rest of them. Okay, so let's say these are what we call the face car. Okay. And how about the hearts? Hearts are cars which in this shoot. Okay, so you see, okay, so let's construct our Venn diagram. Okay, we have number car, use N, with heart I use H. Okay, and how many of them are both number car and heart? Okay. There are number cars and hearts 1 to 10. 1, 2, 3, 4, 5, 6, 7. Okay, up to 10. So 10 of them. How many cars are number cars? Okay, and sorry, how many of cars are hearts but not numbered? Okay, should be 3. So how many of them are number car but not heart? Okay, should be the rest of the number cars which are not heart. Okay, should be. Because each shoot you got 10 number cars, so there are 3 other shoots other than hearts. So there are 30. Okay, so what are the rest of them? Should be 9. So if you don't know how could I get this number, I use 52, take away 10, 30, take away 10, take away 3. You got 9 of it. Okay, so find probability card, number card, and heart. Okay, so should be the 10, right? Why? Well, interested in the because they are n, so you need to find the intersection of two events. Okay, so and we just simplify that. Okay, you get the answer. Alright, so the last one. The probability of the car is a number car or, okay, so this time is or, number car or a heart. Okay, so it should include all the number here, all the number here, all the number here, and we should put our highlight. You consider all the number into 2 circles, and of course this n. Okay, so that's it. Oh, good. Okay, so could you see how could we do these things? Right, of course, for playing cards, you need to know the names of those cards. Okay, and possibly if you have some problem with that, you can Google the names of the playing cards, or you could ask me. Right? Okay, and okay, the last one, a die or face. 6 faces. Row once, find the probability that the number facing up is an even number and multiple of 3. Okay, so okay, so let's say when we roll a card, when we roll a die, how many possible outcomes are there? Okay, let's consider that should be 6 outcomes. Let me draw them. Okay, let me draw them. So 5 of them. Okay, so first one of course is 1, and second one is 2, and then you got 3, and you got 4, you got 5, and you got 6 as well. Okay, so let's see. Number of facing up is the number facing up is an even number and a multiple of 3. So again, you see the word and, so there are actually 2 events, even number, multiple of 3, so there are 2 events. Okay, so first let's think about what are the events. Yeah, what are even numbers? Even numbers means number divided by 2. So of course 2 can be divided by 2. Okay, so that's 1, and 4 is also divided by 2, and also that's 6 also divided by 2. Okay, so for the events of even number, we got 3 of them. Okay, how about multiple of 3? Multiple of 3 means the number can be divided by 3. Alright, so it should be 3, and the other number should be 6. Okay, so 6 is one of them, and also 3. Okay, let's get the 3 out of here. Okay, so 3 is also one of these. Alright, so we got 3, we got 6, and let's see, you need to find that the number is even number and a multiple of 3. Okay, so we construct our Venn diagram. Okay, so let's see, these are okay, possibly I need more room for that. Okay, sorry about this, just create a little bit bigger room for my drawing. Okay, so let's say okay, 2 circles. Okay, so you need to have an even number, so I use E to refer to even number. Multiple of 3, I use M. Okay, so how many cases would it be a even number and also multiple of 3? That's only 1, right? Okay, let's say that's only 1. Let's copy this. Okay, so number 6 will be the case. That's not only this is an even number, okay, but also this is also a multiple of 3. Okay, so how many cases are there for just even number, not the multiple of 3? So there will be 2 others. So there will be 2 others. Okay, right here. And for multiple of 3 but not even number, just 1. Okay. Okay, so how about the rest of them? You still got 1 and 5. Okay, so these 2 are neither of them. Okay, Alright, so let's mark the number. Okay, so you see there's only one case in the intersecting area, so it should be 1. Okay, so that 2 even number but not multiple of 3, and 1 multiple of 3 but not even number, and that 2 which are neither of them. Alright, so could you see that? Okay, so totally that should be 6. So when you add all the numbers, there are 6 of them. Okay, so let's see probability of a even number and a multiple of 3 should be only one such case divided by 6. Okay, so we are actually considering the area here. So let's possibly I should copy this for my next question before I highlight. Okay, so we consider the area here. Okay, so let's move to our next one. Okay, so for this one, find the probability number facing an even number. Okay, it's an even number or, okay, so it's different, isn't it? Even number or a multiple of 3. Okay, even number or a multiple of 3. Okay, so you need to consider this part, and this part. Okay, or this part. Alright, so how many of them? There should be probability E or M. It should be 2 plus 1 plus 1 over 6. Okay, 2 over 3. Okay, you got 4 over 6, then it will be 2 over 3. Okay, alright, and let's move on to okay, I'm running out of a little bit of space. Okay, so find the probability that the number facing up is greater than 2 and an odd number. Okay, so I'm going to do a simpler Venn diagram this time. So what with the numbers greater than 2? Okay, so if we are talking about numbers greater than 2, they should be 3, 4, 5, 6, alright? And odd numbers, okay, so these are greater than 2. Okay, so how about odd numbers? So odd numbers should be 1, 3. Okay, should be okay. Copy these. Sorry. Okay, so but some of them are not, so I'm going to cancel them out. So all numbers are these guys together. So 1, 3, 5, right? Okay, so you see that. So there are 3 of them. Okay, so these are odd numbers. Okay, so this time let me make a Venn diagram. Okay, so we need to have greater than 2. I call this event as G. Odd number I call O. Okay, greater than 2, O. Okay, first you need to see how many in the overlapping area of 2 events. So for greater than 2, you got 3, 4, 5, 6. For O, you got 1, 3, 5. Okay, so actually there are 2 cases which are overlapping. And okay, so for greater than 2 but not odd number, there are another 2 right here. And for odd number, there's another one here. And of course, there should be one case which is neither greater than 2 nor odd number. So there should be one of them. Okay, so let's see. Probability greater than 2 and odd number. Okay. Okay, so how many of them should be only when it's about n, you need to consider the overlapping area. So it should be 2 over 6. Alright. Okay, so the last one, find the probability that's facing up is greater than 2, but this time's or, so last time's n, one odd number. Okay, so let's do this one next. Oh, sorry, I forgot to. Okay, so this time we're going to see greater than 2 or an odd number. So that means you need to highlight all areas in 2 circles. Okay, so that's probability or 2 plus 2 plus 1 over 6, so 5 over 6. Okay, so that will be the case. Okay, right, and okay, so here are all the materials you need to learn. Okay, so you should understand there are 2 kinds of relation between 2 events. It could be and, it could be or. For events using and, we need to consider the overlapping area between the 2 circles. But before that, of course, you have to construct that Venn diagrams successfully. And for events or, you need to consider the all areas, all the numbers within the 2 circles, whether they are overlapping or not. You need to consider all the areas, and sometimes they might ask you neither the 2 events, so it should be the outside of the 2 circles. Okay, so there are all sorts of different questions you need to understand by using your Venn diagram. Okay, so the key for the success of these 2 lessons is about how could you construct a good Venn diagram, a correct Venn diagram. After you got your Venn diagram correct, then the rest of the things are not that difficult for most of you. Okay, right, so that will be our 3rd lesson of probability. See you next time.